welcome back to another video. Here we're looking at a tangent line with slope m, as you can see here. So we're working out a calculus 1 problem. So before I continue, I would like to remind you to subscribe to my channel, like my content, and if you're watching, just be aware that I'm uploading more videos. I'm trying to do that as much as I can. But let's get to the problem. So first of all, definition of a tangent line with a slope m. We're going to do this definition, then after that, at the end, I will work out a problem. So if f is defined on an open interval containing letter c, and if the limit as notated here, the limit as the change in x goes to 0 for the change in y over the change in x is equal to the limit as the change in x goes to 0 of the function f of c plus delta x minus f of c all over delta x is equal to m. So that's the definition. Basically, you have 2 points that define it's a definition for slope. If you recall, it's y1 minus y2 over x1 minus x2. Basically, you have 2 points that you're trying to connect to find that slope line. Alright, that being said, continue with the definition. Exists, then the line passing through C, comma f of c with the slope m is a tangent line to the graph of f at the point C, f of c. Remember, f of c is simply the input on a function, right? Whatever the function has, whatever variables we have on the other side will be replaced by a letter c. And I'll explain that later on as I continue. So the slope of a tangent line to the graph of f at a point C, comma f of c is also called the slope of a tangent line of f at x equal to c. And that is the tangent line with slope m. Okay, so let's take a look at more definition here. We have one of the clarifications here. As you can see, the tangent line is basically having over this graph. As you can tell, as the graph is moving around, so it's my tangent line, and as you can see on this, it's more like the secant line. But you can tell that here, as it doesn't cross out the actual graph, it is still a tangent line. Here's another secant line. That's a secant. So basically we have a curve, let's say, and if that connection is simply hovering over or slightly touching it, this is what we call a tangent. But on the contrary, let's say that it is not doing that, but is actually crossing across. Or let me use a different color. Maybe use green. So if it actually crosses out the line, just like so, this is what we call it a secant line. Alright, so let's move along. So the definition of a tangent line with slope m, as we just looked at that before, this is continuation. I was just demonstrating these key points here. Let's go to the next page. Here's an example of what I was illustrating. So here's a function f of x equals to x squared plus 1. And the tangent line at 0, comma 1, as you can see here. The tangent line at 0, comma 1 illustrated. So basically you have a point where x and y, so x is equal to 0, y is equal to 1. So the point x equals 0, y equals to 1 should be somewhere in here, right? X 0 and y 1. So sorry about that. So the actual point as you can see, it's somewhere in here, right? Because my x has to be 0, but it's actually down here. There you go. And my tangent line at x and y, so -2 and then y2, is actually going right here. As you can see, it just barely touches it. Now let's work out this problem and do the actual formula. So here's my definition. Once again, the limit as delta x goes to 0 of the change in y over the change in x. So we're going to take a look at that. Just remember as a side note, let's say that f of x, for instance, is equal to 2x, just to make it simple. So if we're doing that, then f of 1 is equal to 2 times 1. And as you can see, we're basically replacing the x value for whatever term we have here, as well noted here. Just like so up here. So maybe we do f of 2, and you have a 2 there, standard 2, and then x becomes 2, therefore it's 4. That's the way you find out something like f of a variable or a number. Maybe in this case is c plus delta x, just like we have here, right, in the formula. So now let's bring this equation down here. So we have f of x equal to x squared plus 1. Once again, we need to find out what my mx, so we can do the y equals mx plus b. That's what we're looking for. So if I try to do that based on this illustration here, so I will do f of c plus delta x equal to, as you can see, I am replacing x for this whole piece. So every time that I see an x, that will be replaced by c plus delta x square. As you can see that illustration here, there's an x. So all of that became c plus delta x, and we still have the square there. Okay, so let's continue. Plus a 1 there. So nothing wrong with that. Now we're ready to expand that. So we have c plus delta x times c plus delta x plus 1. So that's what we have so far. Now let's do distribution here. So we end up with c squared. And then if I multiply this times that, I get plus c delta x. And as you can see the relationship, this duplicates plus c delta x. And then, of course, we get a plus delta x. I'm going to use square brackets here to illustrate that square. We still have a 1 there, this one here. All right, so now we're ready to combine like terms. We still have a equal sign there, so we have c squared plus, and we have these two here, so that make up a 2 delta x, and we have a plus sign there. We still have a delta x squared plus 1. Okay, so now we have located the actual number here for our value f of c plus delta x. So what is f of c? So that's pretty simple. It's pretty straightforward. So if we're trying to locate f of c, once again, just to illustrate that point, f of x is equal to x squared plus 1. So therefore, when I'm doing f of letter c equal to, all I'm doing is, once again, I'm replacing the value of x everywhere that I see it on the other side. So here's an x value, so that will be c squared, and I still have a 1 there. So that is my f of c. and I still have a delta x down there. So let's set it up. Let's scroll down a little bit more, and here we go. Okay, so now that we're ready, we can simply continue with that definition of the limit, and you will get penalized if you don't do that. So I'm going to illustrate that. And then after that, I'm just going to continue saying equal. So this is a y, change in y over change in x equals to the limit as delta x approaches 0. And then we have f of c plus delta x. And then just keep in mind delta x f of c. I'm going to go back. I'm going to erase that piece just to make sure that I have that term now. Now that I know what my delta, now that I know that I have that term here, as you can see, this is f of c plus delta x, and it's down here already there. So all I need to do is, instead of saying f of c plus delta x, I'm just going to notate c squared plus 2, okay, yep, I think I'm missing something. Yeah, there's a c letter there. So 2, should be a c there, so sorry about that. Should be a c, letter c there. Okay, so 2c delta x, and then plus the square, okay, delta x square plus 1. So that is what I have for this piece right here. I have a minus sign, and then I encourage you to always use square brackets after the minus sign on any kind of term, just to make sure that you distribute the minus afterwards. So here's my plus minus f of c, and I know that f of c is here already. So all I need is the end result, which is c squared plus 1. And this is all over, based on the definition here, delta x. Okay, so I need to continue. And I'm going to illustrate this point just by ignoring this for now. Unfortunately, or fortunately, you have to continue when you're in school. You have to keep adding. I'm just going to say equal. And then the limit of delta x goes to 0 for now. So I have c squared plus 2c delta x plus the square bracket of delta x squared plus 1. And then I have a minus sign here that I need to distribute here and here. So I have a minus c squared minus 1. Okay, and that's all over delta x. All right, now that I have that, delta x, it's kind of sloppy there. So I'm seeing the relationship here. I can see that c squared and c squared are opposite. Here I have a positive, here I have a negative. They eliminate each other. Here I have a plus 1, and I have a minus 1 there. So they're both eliminating each other. Okay, now I'm left up with, okay, once again, we need to do the limit as delta x approaches 0. I'm left off with 2c delta x plus delta x within square brackets, and I can simply simplify it by simply separating the terms, just like so. And this is more or less like when you have, let's say, for instance, 5x plus 1 all over, let's say, maybe 7. So yeah, this is also can be split into 5x over 7 plus 1 over 7. So that's technically what I did here. All right, let's continue. So we have the limit as delta x goes to 0. And here I have simplification here. We have delta x, and delta x crosses out. Just as if you have, let's say, for instance, let's say 2x over x, and you can see the x's cross out. So that's more or less a simplification that we're doing here for those x squares. And then in here, I only eliminate one of the x squares. So I'm left off with 2c plus delta x. And I forgot the 0 here. Sorry about that. Now I'm ready to add the limit onto this expression. And when I do so, here it is, limit as delta x goes to 0. I have a 2c plus, and then there's a delta x. I need to add that as a 0. And that crosses out. Simply, the answer is 2c. And that's what I call m. So that is my slope. Now, if you recall, my initial equation is equal to f of x equal to x squared plus 1. But if I'm asked you to find an actual point, let's say, for instance, find the actual equation y equals mx plus b. So I can say at point, maybe, let's say, let's make it simple. Let's say 0, 1. So I want to know this is x, this is y. Once again, my m and my letter c, based on the definition here, it's in terms of x's. As you can see here, my c represents the value of x. Okay, so that being said, we go back to our problem here. And so if that is the case, I will simply assume I have m equals to 2x, and therefore m equal to 2, and then if I put in a 0 there for x, 0 equals to 0, so m is equal to 0. So if m is equal to 0, I still have my y equals mx plus b. So if I want to know what the b value is, all I can put in is my x and my y based on these points here, or this point actually. So then, therefore, my y value here, it's equal to 1. Oops, it should be an equal sign. My m value, we know it's 0. My x value, it's equal to, oops, I think I messed up here. Oh, no, I'm right. Sorry about that. So y is equal to 1. My x is equal to 0 plus b. We know that our y value, or b, is equal to 1. So now we have our equation, y equals to m, which is equal to 0, x plus 1. And anytime the value of m is equal to 0, we get y equals 1. So that is our final equation. So y equals to 1 is simply a value of y1. So 1, 2, let's say this is 1 and 2 in our x and y coordinate. This is my x, this is my y. So y equals to 1 is simply a horizontal line. It never changes. And if we go back to our graph, here it is. So x squared plus 1. We can see that our tangent line is right here and down here. And here's my x equal to 0. Here's my x. I'm sorry, my y equals to 0. Here's my y equals to 1, just like we had in our graph. All right, I hope you like this definition and the problem that I just did for you. If you like the content, once again, please subscribe, like what you're seeing, and hopefully more people are joining my channel. And thank you so much, guys, for watching. You guys stay tuned. Goodbye.